Cool. Great, thanks. So now we're going into the more like the theme of the event. So we're going to be talking about government. We're going to be talking about macroeconomic data, and we're going to be talking about law. So to start with, we have the folks from FiscalNote. Can you guys come up? Who are doing some super interesting things in around government data.
All right.
Take it away. You both mic'd up, right? Or do you need another mic?
I think it needs a mic. Okay. So hi, my name is Tim. While he's getting set up, I'm the CEO of FiscalNote. Basically, what it is, it's a real-time predictive analytics platform for state and local legislation. And today, I'm going to be talking a little bit about lessons that we've learned from unlocking unstructured government data. So to give you a little bit of background, the problem that we're trying to solve essentially stems down to the fact that 90 to 95% of government data is unstructured. There's a lot of companies out there that are trying to crunch economic data, crime statistics, education or health statistics, but the traditional approaches right now just aren't getting at the main drivers of government policy, which is actually unstructured. So we're talking here about legislation, regulatory text, case law, and a lot of other things. And so what results in what the current market looks like is that law and policy analysis as it is currently very restricted by human capital. So you're seeing this within policy shops, you're seeing this within law firms, you're seeing this within lobbying shops that are all trying to do the same thing in terms of analysis through sort of very human-intensive methods. So think hundreds of different analysts or policy analysts that are sitting around looking at different computers, trying to aggregate data, trying to analyze and understand what the impact might be. So what we're trying to do is take both a computational as well as a political approach to understanding this unstructured data. So I'm going to talk a little bit about sort of the limitations of human analysis. So I talked a little bit about how the current setup of unstructured data is set up, right? So it's all legislation, it's all very complex legal text. And this problem is actually complicated by the fact that our government is very, very complicated. So let's think about this for a second, right? You have one federal government, everyone tracks the federal government, everyone tracks Congress and the White House. But let's expand that a little bit more. $4 trillion in spending just at the state and local levels. There are 50 state governments in the United States, 3,144 county governments, and over 19,000 municipal governments that are all passing laws on education, zoning, property laws, health laws. And we're tracking. So there's I think a huge sort of information asymmetry when it comes to trying to understand these main drivers of policy. So when you expand this out to sort of the international level, just taking Germany as an example, you have 16 states, the law under state governments, and then you have over 12,000 municipal governments that are all passing laws on a range of different topics that are impacting industry, from tourism to zoning, again to property law, which is a huge state and local issue. And you complicate this by expanding this out to almost 200 different countries that all very, very similar or very, very different governments. And what this results in is a lot of uncertainty. So you can look at this in the markets when something like even something as momentous as the Patient Protection Affordable Care Act passes. You see things like massive stock movements, but people don't really understand what's in the piece of legislation. And it in a market-driven economy that's very, very time sensitive, being able to go through a 6,000-page piece of legislation in under a minute is going to be tremendously valuable. And so basically what we've done is we've been able to create a platform that mines vast amounts of government data in legislation and regulatory text and case law, analyze the probability of a bill passage for right now. This is our first product called Fiscal Prophecy, and predicts whether or not a bill is going to pass. Currently, our prediction algorithms are about 94% accurate in being able to determine at first reader whether or not a bill is going to pass. So on the platform, what a user is able to do essentially is search any piece of legislation that's catered towards their industry, monitor any industry-level activity based off of legislative or regulatory changes, and then have a fairly good understanding of whether or not this is going to pass. So two use cases that I want to talk about. So the first that we're seeing is actually in portfolio management. So as state legislatures become more active, portfolios actually may be overexposed to government legislation, regulation, and underexposed to opportunities. So things like tax credits or things like opportunities, market opening opportunities and regulations. So the solution that FiscalNote has come up with in this particular space is to offer them the tracking and prediction algorithms that provide for deep insights in optimizing their portfolio strategy and monitoring legislation. So one of the things that we're tracking very closely right now is something like the state internet sales tax. So companies like Amazon, eBay, a bunch of these others, they're incredibly overexposed to these types of legislation. And right now, I will tell you that I think a lot of lobbyists, a lot of in-house general counsel, they're just sort of running around trying to understand whether or not a bill is going to come out, whether or not this is going to pass, whether or not they're going to be charged millions and millions of dollars in tax liabilities as a result of some of these things that are coming down the line. Second thing is in equity research. So state legislation obviously impacts almost $4 trillion in our economy spending today, and one of our clients, Wedbush, is using our platform to understand whether or not sort of the budget and taxation bills that are coming through the line are impacting certain industries, whether or not if there's particular contracts that are coming down the line that might have tremendous implications for certain companies as well. And what I'm going to do is actually bring up my senior principal scientist, Vlad. He's going to take you a little bit more of the technical details through our platform.
Thanks, Tim. So I'll give a brief overview of some of the technical challenges that we have to encounter when we're trying to do this platform. So the first one, and arguably the most crucial, is acquisition or aggregation of all this data from the different state and local governments. And I wouldn't shock anyone here by saying that's actually one of the hardest parts that gives us the most headache in trying to do that right. So we've spent a lot of time in developing technology and partnerships to aggregate the right data in a nice, clean format that we can actually use right away in a timely format. So minimally what we want is to have the legislative text, the bills themselves, and information about the legislators. And then on top of that, what we try to do is aggregate as much more information as possible, so demographic, geographic information, spending, any sort of special interests, anything that would let us discriminate further about the likelihood of certain bills' passage. And then once we aggregate these bills, then our problem is basically categorizing them into predefined categories that our users expect to see when they want to track and monitor legislation. So it's sort of the usual clustering categorization problem with some specific tweaks here. So we have these predefined top-level categories that we encounter, and our data is not labeled with these. So what we've done, the solution that we've settled on now, is basically bootstrapping a labeled data set in a semi-supervised fashion. So we did a couple of different unsupervised analyses, took good clusters that we thought represented these industries and categories well, and then created a data set from that and trained different classifiers that we then run. And then within each category, a bill can be labeled within multiple things. So if we have a bill about after-school programs in science for low-income or underprivileged kids, then each of our users who might be tracking education or science would want to be notified. So we have to be accurate about how we categorize a bill, and then we have to be able to subcategorize these within each one. So a bill could have multiple categories and then multiple subcategories within that one. So then we basically do a couple of different unsupervised analyses to split bigger clusters in data-driven ways and merge them back and then map a bill that could be in multiple things. So there's quite a bit of machine learning that goes into doing that accurately in a timely fashion. So as soon as a new bill comes in, we're able to notify our user of any changes. And then this, the pie graph on the left is showing a basic representation of overall the 50 states broken down by industry, amount of bills in each industry. So you can see that some of the bigger categories like budget and spending, obviously that would include a lot of subcategories that would fit into the other things like education, health, energy. And then on the right, you'll see an excerpt from the hierarchy that we create. So something like, and then the top levels are insurance, employment, and health, 3 of the top level categories. And then beneath each one are the most discriminant or the most likely words from within a subcategory. So for instance, the one that's kind of green, orange, and blue, That's obviously worker compensation, employment, injury, medical insurance. So that would be related to a very specific subset of bills, but it's also related to a lot of other bills that we have to map and keep track of. So then once we categorize these bills, then obviously we want to do some sort of analysis on them and predict several different things at this point. So the stages for the normal stages for a bill are it's introduced, and then it might go to committee, it might not. And then if it comes out of committee, which it might not, there might be a vote on it, which it passes or fails. So we have fairly fine-grained models that go into the detailed processes within each one. So the first major one is modeling on the stages. So how likely is a bill to get out of the committee, assuming that it's assigned to one after it's introduced? And the baseline for this is very high. The dominant class is that it's not. Most bills die in committee. And most things that take place within a committee are not very accessible to the public. So that is a challenging thing to model. And then after that, assuming it does get out of committee, how likely is this bill to pass a floor vote? And that baseline is very high. So most bills that do come to a floor vote will pass. So even improving the classification several points on top of that gives us a huge reduction in the error. And then for each state, obviously there's different legislative makeup, different legislators, different prior notions of what is going to be likely or not. So we have, basically this is our current R&D right here. What are the things that are likely to influence how people are going to vote? So we utilize the bill, we utilize any legislator information in the legislature information, and then any of the other things that I talked about earlier that we aggregate. And we have several models that we're exploring for this particular stage. And on the right, I just have one graph of how you can look at the data, which is intensity based on how many bills were introduced in that state. So no surprise, New York has the most bills introduced. But then surprisingly, for instance, for us, Hawaii has the 5th largest number after Texas, Illinois, and Tennessee. So that's a nice high-level overview, but then we can do different things with it. We can show different similarities. And then what we're planning to do is go into predicting which legislation might be proposed, not just how likely a proposed piece of legislation is to succeed. So then looking at similarities on a local and state level, if this bill was proposed here, how likely is it to come out in certain timeframes in these other places? So one step further in the prediction process. And this is just a simple UI of what you see, that we saw earlier. So on the right, you have the passage score, the probability that a bill is going to pass, some statistics about the legislators, the sponsors, and then we have a ranked list, or the first one is not ranked, it's people who are likely to vote, so by name of the people who are going to vote on this bill, and then below that, there's a ranked list of others who vote and other pieces of information that our customers might find useful.
So the secondary analysis that we're working on right now includes some very advanced natural language processing. And what we need to do is actually, in order to be able to run a lot of these analysis, you have to take a legislative bill similar to this and try and understand the different pieces of it, right? So very, very simply, what's the session that it's coming out of? What's the bill ID? What's the summary of the bill? Who are the sponsors? And link all those sponsors back to our database of demographic and political and campaign finance data, and then understand the legislative text itself. One very important nuance that I want to point on is that this isn't, some bag of words approach that we're trying to take here. Legislation is incredibly complex. And one example that I would point out is, the example I have here. So you have two simple sentences. If you swap out the period in the middle for a comma, essentially what happens is that second sentence becomes a dependent clause of the first sentence. And what that essentially means is that when it gets to regulation, that essentially completely changes the meaning of the actual bill text, and that has implications for our predictive analysis, as well as a lot of the more complex analysis that we're trying to do. So to conclude, I want to sort of talk about three relationships that we're trying to disrupt here. So, right, the first is actually the relationship between legislation and regulation. So as legislation gets pushed out into the regulatory agencies, there is a lot of sort of organizational inefficiencies that come out as a result of the fact that you're trying to understand those types of relationships like the comma or the period. And the second type of relationship that we're trying to look at is sort of the relationship between information and decision makers, whether that's a corporate executive or a financial analyst. We're essentially removing a lot of the base level data aggregation and analytics in order to sort of help them spend a lot more of their time trying to maneuver through regulations or try and understand how their organizations might be impacted by them. And then the last, of course, is the relationship between the citizen and its government, whether it's a corporate citizen or an individual. Anytime, I think we can all appreciate the fact that right now there seems to be a lot of uncertainty in the markets as a result of government and government actions. And this has huge implications for how we function as citizens. And that's sort of the big relationship that we're trying to get at. And so I'd be happy to take any questions after that.
Very cool. Thank you. So Matt has the first question.
Can you talk a little bit about who you think the customers are? I think you mentioned finance firms. Obviously, for them to use this, it's a couple of putts versus, like, say, lobbyists or all the Fortune 500 companies that have big lobbying teams and government relations. Just curious who you think the customers are.
Yeah.
And for background, so Matt spoke before you arrived, and he's the former head of research at Bridgewater, and now an entrepreneur.
Great. So I think we can sort of put our customers into three different categories. The first category is your typical K Street firm. And so K Street loves this product. It essentially allows them to do two things, which is one, conduct a lot of the base level research that they're doing with their current policy analysts. And two is actually, very interestingly, it allows them to do a lot of prospecting. And so currently, the way K Street operates is you have to pick out a bill, and they come to you and they say, this is a huge liability for your organization. Do you want us to represent you on retainer? And so K Street is using this product for that. The second is actually, again, in financial institutions. So whether that's doing and trying to understand potential risks in portfolios, or in trying to understand potential changes in spending around particular industries, that's something that we're helping a lot of financial institutions do as well. And the third is sort of around compliance. So Fortune 500s, huge general counsel offices, public affairs divisions within these organizations are finding a lot of use in trying and reducing a lot of the uncertainty that happens when you're working particularly in an industry that's heavily regulated. So something like energy or healthcare. One of the bills that we actually just predicted yesterday passed, and it helped an organization to sort of maneuver through changes in their product pipeline as a result of sort of these different changes in government. So I think there are a lot of different use cases, and we are experimenting with all three of them.
Hi, I'm Larry Schiller with Learners High. Your engine, how flexible is it and how architecturally separated are the layers? In other words, for example, if someone, if a trial lawyer wanted to figure the probability of success or failure in a trial, could your engine be applied to that if someone had the right models to pour into it?
Yeah, I mean, that is something that we are working on. So we don't actually have that right now, but I think there's a lot of very interesting applications as we start to move out to regulations and to case law, and inputting the same and using the same architecture essentially for trying to predict different outcomes. So we actually joke around in the office a lot about how in the future we might have something like high-frequency litigation, and that's I don't think that's too far from the truth in terms of being able to understand and predict these types of outcomes based off of past data sets.
Rob Burkowski, Roof Asset. The question comes from the comment you made at the beginning in terms of the predictive capability that you have, which I'm curious about the back testing that you did, because I wonder if a Congress is all one party, the White House is all one party, whatever. And when you did I presume you did the back testing on this, how that changed based on the political makeup or the political party makeup of the government.
Right. So we actually didn't run it on Congress. I mean, a lot of the algorithms that we're targeted are very specific for state legislation. But we did back test it around 7 to 8 years now, depending on the state. And a lot of the parties do change depending on the state. But to be fair, a state like New York, I don't think you're not really going to get a change in terms of political party composure. And in terms of our back testing, it doesn't seem to have a huge, tremendous impact in the way it affects our platform right now.
Mike Rosen, 1010 Data. Have you considered linking it with other external data sets? For instance, in the equities example, doing predictions not just on like what the how the law will pass or fail, but which stocks will be impacted as well, and will they go up and down?
Right. Actually, so one of the things we're doing right now is because a lot of our platform takes into account the labor statistics and employment data from demographic data, we can actually extrapolate who the largest employers are in a particular district or a particular legislative district. And so as a result, we can understand first, so you can think about it from two sides, right? The first is where the legislation is actually coming from, who's actually introducing the bills, and the second is who's going to be impacted by that. And so and that is something that we are working on in terms of linking those two data sets, like a labor statistics data or like stocks, and understanding what the implications are for particular corporations that are impacted by a particular bill.
Well, with the focus on state and local, is that because it's a less competitive space, or is there something intrinsically more predictable about state and local as opposed to federal?
I think it's both, right? So the first is that a lot of the information asymmetry stem from the structural system of government that we have. The 3,000 counties and the 20,000 cities. A lot of this information is very, very hard to get, and so that's the first thing, and that's why it makes it there's not a lot of competition. But the second thing is that because a lot of states and because a lot of city councils are one party or have traditional voting patterns, we're able to extrapolate a lot of those out, and they become a lot more predictable when it comes to running these types of analytics.
Hi, Jonathan Dayton, Love Crossing. I think earlier you mentioned that you have a 95% accuracy rate, and I'm just wondering, with most bills not passing, how does that break down versus in bills that do pass versus bills that do not pass?
So that's a very good question. So it actually depends based on the state. So I think for Texas, for example, about half of the bills do pass. For a state like Pennsylvania, a lot less of those bills pass. In New York, I think something like 93 or 94% of bills end up failing, by the time they get to committee. So there's a lot of variability when it comes to the states, and like Vlad said, these baselines do change a lot from state to state, but our algorithms in terms of prediction are able to account for a lot of these things. And the way we think about it is not sort of measuring it against the baseline, but being able to surface a lot of the bills that come out even before they get voted on at third reader.
Great. Last one. Okay, you get the last one. I see the pat here.
Okay. Hi, GW. Just in general, you said you had 50 models for the 50 states. How many variables are in each model, just roughly? So in other words, I know you had to have a variable for Democrat, a variable for Republicans, but in general, how many variables in just generally?
Yeah, so I don't know the exact number off the top of my head, but there's probably hundreds that we take into account.
Per model?
Yeah.
Great, thank you very much. We're actually a little over time, but you're going to be around.
Thank you.